Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as definite integrals. Let's see the sum. Integral of 0 to a x square a minus x raised to 3 by 2 dx. I'll say let I equal to 0 to a x square a minus x raised to 3 by 2 dx. Now if I use the formula integral of 0 to a f of x dx, I can say integral of 0 to a f of a minus x dx, in which case I will get I is equal to integral of 0 to a, this is going to be a minus x the whole square into a minus x the whole raised to 3 by 2 dx, right? So in this case, this can be written as integral of 0 to a minus x the whole square is a square minus 2ax plus x square. This is a minus a plus x raised to 3 by 2 dx. This can be written as integral of 0 to a square minus 2ax plus x square, and this is nothing but x raised to 3 by 2 dx. Open the brackets and simplify. This is 0 to a square x raised to 3 by 2 minus 2ax x raised to 3 by 2 plus x square x raised to 3 by 2 dx. This can be written as integral of 0 to a square x raised to 3 by 2 minus 2a 1 plus 3 by 2 5 by 2 plus x 4 plus 3 by 2 7 by 2 dx. This can be written as integral, I can take the constants out and split the integral, a square 0 to a x raised to 3 by 2 dx minus 2a integral of x raised to 5 by 2 dx plus integral of x raised to 7 by 2 dx a square. Now x raised to 3 by 2 can be written as 3 by 2 plus 1, that is x raised to 5 by 2 upon 5 by 2 minus 2a x raised to 5 by 2 plus 1 is x raised to 7 by 2 upon 7 by 2 plus x raised to 7 by 2 is 9 by 2 plus c. So in that case you can say that this is nothing but 2 upon 5 a square x raised to 5 by 2 minus 4 upon 7 a x raised to 7 by 2 plus 2 upon 9 x raised to 9 by 2. When the limits are from 0 to a, here you have limits are from 0 to a, limits are from 0 to a, limits are from 0 to a. So this is going to be 2 by 5 a square x raised to 5 by 2 when the limits are between 0 to a plus 4 by 7 a x raised to 7 by 2 when the limits are between 0 to a plus 2 by 9 x raised to 9 by 2 when the limits are between 0 to a. Now upper limit minus lower limit. So this is going to be a raised to 5 by 2 minus 0, a raised to 7 by 2 minus 0 plus a raised to 9 by 2 minus 0. Right, this can be written as 2 by 5 a square a raised to 5 by 2 plus 4 by 7 a raised to 7 by 2 plus 2 by 9 a raised to 9 by 2. So this can be written as,
so isn't it minus 4 by 7?
yeah, it's minus 4 by 7. So this is going to be 2 by 5 a raised to 9 by 2 minus 4 by 7 a raised to 9 by 2 plus 2 by 9 a raised to 9 by 2. That's 2 by 5 minus 4 by 7 plus 2 by 9 a raised to 9 by 2. So this is going to be, you could take an LCM here. This is 5 into 7 into 9 as the common denominator. 7 nines are 63. 126 minus 45. 180 plus 7 5 are 35. 70. A raised to 9 by 2. So this can be written as 126, 196, 180. So 16 upon 5 into 7 into 9. A raised to 9 by 2. 35. 350, 330, 320, 315. A raised to 9 by 2. Right? Next, let's see the next sum, guys. Integral of 0 to 4 dx x plus root of 16 minus x square. Right? Now I have 16 minus x square. I need to make sure that I get rid of that 16 minus x square. Right? And I have the next term as x square. Okay? In that case, to get rid of the 16, I'll say let x be equal to 4, because when I square that, I'll have 16 common, right? And I want to substitute, so I'll say that now this is, suppose if this is sine theta, then this would have been 1 minus sine square theta, that would have been cos square theta. So I would get the same term. So I can say let x be equal to 4 sine theta, right? If I say that let x be equal to 4 sine theta, let's differentiate with respect to x. If I differentiate with respect to theta, I'll get d by d theta of x is 4. D by d theta of sine theta is cos theta. So I'll get dx is 4 cos theta d theta when x is equal to 0 and when x is equal to 4. Theta is equal to, now when x is equal to 0, sine of 0, here this is 0. So in that case sine of 0 is 0. And when x is equal to 4, you will get this as sine of 1. Sine 1 is nothing but 90. So I can therefore say that I is integral of 0 to pi by 2. Instead of writing 0 to 4, for 0 the limit is 0, for 4 the limit is pi by 2.
X is pi by 2.
Yeah, x is pi, theta is pi by 2. I am substituting the upper limit with pi by 2. I have to substitute the limits of x with theta. I am substituting. Dx can be written as 4 cos theta d theta upon x 4 sin theta plus square root of 16 minus 4 sin theta the whole square, right? Now this can be written as integral of 0 to pi by 2 4 cos theta upon 4 sin theta plus square root of 16 minus 16 sin square theta d theta. This can be written as 0 to pi by 2 4 cos theta upon 4 sin theta plus square root of 16 1 minus sin square theta, right? So in that case this can be written as 0 to pi by 2 4 sin theta upon 4 sin theta plus square root of 16 cos square theta, right? This can be written as 0 to pi by 2 4 sin theta upon 4 sin theta plus 4 cos theta. Let this be equal to equation 1. Wait, I still can take 4 common. 0 to pi by 2, I can say 4 sin theta.
Cos theta.
So I've written 4 cos theta by
4 sin theta.
4 cos theta. Four common. This is sin theta plus cos theta d theta. Right? In which case 4 and 4 gets cancelled. Now, so in that case I'll say I is equal to integral of 0 to pi by 2 cos theta upon sin theta plus cos theta d theta. Right? Let's call this as equation 1. Now, I can say that I is equal to, if I use the formula integral of 0 to a f of x dx, I can say it is equal to 0 to a f of a minus x. So this is 0 to pi by 2 cos pi by 2 minus theta upon sin pi by 2 minus theta plus cos pi by 2 minus theta d theta. So I'll get I is 0 to pi by 2 cos 90 minus theta is sin theta, sin 90 minus theta is cos theta, cos 90 minus theta is sin theta d theta. Let's call this as equation 2. Add equation 1 and 2. If I add equation 1 and 2, I'll get I plus I, that's 2I is integral of 0 to pi by 2 cos theta upon sin theta plus cos theta d theta plus 0 to pi by 2 sin theta upon cos theta plus sin theta d theta. This is 0 to pi by 2. I can take cos theta plus sin theta as the common denominator, in which case I'll get cos theta plus sin theta d theta, 0 to pi by 2 d theta. This is going to be nothing but theta when the limits are between 0 to pi by 2. I can say 2I is equal to pi by 2 minus 0. I is equal to pi by 2. Fine. Next, take on next one please. Integral of 0 to pi by 4 log 1 plus tan x dx. Now let's assume that I is 0 to pi by 4 log 1 plus tan x dx. This can be written as 0 to pi by 4 log 1 plus tan pi by 4 minus x dx. I'm using the formula integral of 0 to a f of x is nothing but 0 to a f of a minus x. Now let's solve this. This can be written as 0 to pi by 4 log 1 plus, I can use addition formula here, tan a minus b. Tan a minus b is nothing but tan a minus tan b upon 1 plus tan a tan b dx. Right? Now this can be written as integral of 0 to pi by 2 log, this is 1 plus tan pi by 4 is 1. So 1 minus tan x upon 1 plus tan x dx. Right? So in which case you will get this as 0 to pi by 2 log, this is 1 plus tan x plus 1 minus tan x upon 1 plus tan x dx. This could be written as 0 to pi by 4 log 1 2 plus tan x minus tan x 1 1 plus tan x dx, right? Now log a upon b can be written as log a minus log b, 0 to pi by 4. This is going to be nothing but log 2 minus log 1 plus tan x dx. Log a upon b can be written as log a minus log b. Now split the integral sign. This is integral of 0 to pi by 4 log 2 dx minus integral of 0 to pi by 4 log 1 plus tan x dx, right? I will take log 2 common outside. Zero to pi by 4 dx minus. Now, if you look at the sum, if you look at the question right in the beginning, they've said that we have assumed right in the beginning that integral of 0 to pi by 4 log 1 plus tan x dx is nothing but I, right? So this can be written as I. Log of 1 plus tan x dx can be written as I. Take I on the other side, so I'll get I plus I. 2I is log 2 integral of 0 to pi by 4 dx. 2I is log 2 x when the limits are 0 to pi by 4. 2I is log 2 upper limit minus lower limit, pi by 4 minus 0. So in that case you will get this answer as I is equal to pi by 8 log 2. Fine. Let's see another sentence. Zero to pi x sin x upon 1 plus cos square x dx. Now let's see this. We can say I is equal to integral of 0 to pi x sin x upon 1 plus cos square x dx. This can be written as 0 to pi. This is upper limit minus x sin upper limit minus x upon 1 plus cos square upper limit minus x dx. I'm using the formula integral of 0 to a f of x dx is integral of 0 to a f of a minus x dx. Now this can be written as 0 to pi I minus x sin 180 minus theta, sin 180 minus theta second quadrant. In second quadrant sine ratio is positive. Since it is pi, the trigo ratio remains as it is, so this will be sin x 1 plus cos 180 minus theta, cos 180 minus theta second quadrant cos ratio is negative, so it is going to be minus cos theta, but since it is square, minus square will give you plus, so this will be cos square x. I should have got minus cos x the whole square will give you plus cos x, right? Now split this up. This is integral of 0 to pi. This is pi sin x minus pi sin x x sin x upon 1 plus cos square x dx, right? With the numerator, that's 0 to pi sin x upon 1 plus cos square x dx minus 0 to pi x sin x upon 1 plus cos square x dx, right? Constant comes out. 0 to pi is a constant, comes out. This is sin x upon 1 plus cos square x dx minus x sin x upon 1 plus cos square x dx is nothing but I. x sin x upon 1 plus cos square x is nothing but pi. Now this can be taken on the other side, so I'll get 2i is integral of 0 to pi outside sin x upon 1 plus cos square x dx. Now let cos x be equal to t. Differentiate with respect to x. Minus sin x is dt by dx, in which case you will get dx is dt upon minus sin x. So I can therefore say that 2i is pi 0 to pi. No. Since you are doing definite integrals, you have to substitute the limits also. When x is equal to 0, when x is equal to pi, in that case t, when x is 0, cos of 0 is 1. When x is equal to pi, cos 180 is minus 1. So you will get this as 2i is pi. For 0 you are going to write 1. For pi you are going to write minus 1. Sin x upon 1 plus t square. This is going to be dt upon minus sin x. Sin x gets cancelled, so I'll get 2i is minus pi 1 to minus 1, 1 upon 1 plus t square dt, right? In which case you have a formula. If I use the formula, integral of minus a to b f of x dx can be written as integral of b to a f of x dx. Right? If you have a negative sign, to get rid of the negative sign, you change the positions of the limits. If I use this formula, then I'll get 2i is pi limit of minus 1 to 1, 1 upon 1 plus t square dt. Fine, do we get this thing here? Now, let us assume, guys, let's leave this here. Let us assume that f of x is 1 upon 1 plus t square. Let's leave that sum there, and let us assume that f of x is equal to 1 upon 1 plus t square. Now let's find out f of minus x. Right? So f of minus x will be 1 upon 1 plus, instead of x, take this as t. I'm substituting t as minus t. I'm substituting t as minus t on the left hand side, so on the right hand side also I'll have to substitute t as minus t. So f of minus t will be nothing but 1 upon 1 plus t square, because minus t the whole square will give you t square. That means I'll get f of minus t is equal to f of t. Now since f of minus t is equal to f of t, therefore I can say that f of t is an even function. Right? Since f of t is an even function, for even functions you have a formula that I could use the formula that integral of minus a to a f of x dx for even functions is given by the formula twice 0 to a f of x dx. If I use the formula integral of minus a to a f of x dx is equal to twice 0 to a f of x dx for even functions. So if I use this formula, I'll get f of 2i is pi. Instead of writing minus 1 to 1, this will become twice 0 to 1, 1 upon 1 plus t square dt. Right? integral of 1 upon 1 plus t square is nothing but tan inverse of t. 2 and 2 gets cancelled. I'll get I is equal to pi tan inverse of t when the limits are between 0 to 1 pi. This is nothing but tan inverse of 1 minus tan inverse of 0 pi. Tan inverse of 1, we know that tan 45 is 1, so tan inverse of 1 will be 45. Tan inverse of 0 is 0. This is pi square upon 4. So the answer for that is going to be equal to pi square upon 4. Fine, do we get this thing here? Right. We will stop this here for the day. Thank you very much.